So here with number 3, and one of the things to notice on number 3 right out of the gate is that our leading term, our A term right there, is negative. And so since it's negative, we know that this parabola is going to open down like that. It's going to look like a sad face. That being said, we're asked to do the exact same thing in this problem as we were the last one. So again, we've got quite a bit of work ahead of us, but nothing super difficult, just kind of time consuming and laborious. And so we've got negative b over 2a for our vertex formula. I'm going to go ahead and graph this one on that graphing software so we can see what this is going to look like and kind of go from there. Okay, and so we can see that if I graph this one in GeoGebra, what it's going to look like is our vertex is going to end up being right there at the coordinate 1, negative 2. And then if I was to go like 1 unit to the left back to 0, I would end up at negative 4. And remember, these are symmetrical, so if I go 1 unit to the right, so from 1 to 2, I also land at negative 4. And so again, as we graph these things, we want to keep close to the vertex, like only going 1 unit to the left or 1 unit to the right, because if we go far, like over to negative 2, it's going to drop way down here and be way off of our graph. And so we can see from this graphing software that our vertex is going to be at 1, negative 2. We're going to have a parabola that opens downward, and it's going to look like that when we're done with this thing. So let's go ahead with negative b over 2a. Negative b is going to be negative 4 over 2a. A is negative 2. So we've got negative 4 over negative 4, which is a positive 1. Now remember that that's our x value. And to get the y value, we need to put the x value back into the original equation. So our we need to, I don't know what I just said, but to get the y value, we need to put the x value back into the original equation. So there we go. Plus 4 times x, our x value is 1. And so we've got y is equal to negative 2 times 1 squared is 1. Plus 4 times 1 is 4, minus 4. And so negative 2 plus 4 minus 4. So negative 2 plus 4 makes 2, minus 4 makes negative 2. So our vertex is going to be at the point x value 1, y value negative 2. And if we come back and look at that graph, we can see that we did end up at 1, negative 2. So we got the right thing. We agree with the graphing software. And if we were to come down here, now I'll leave this here for people for a moment. And then if we were to come down here, we are asked to make another graph for this equation. And we know our vertex is going to be at 1, negative 2. So the vertex is going to land right there. And this thing is going to open downward, so it's going to look something like that. We want to have a better representation than what I just drew, though. And so what we need is points to the left and to the right. And so if we think about what's to the left of that point, we have a 0 value, we have a negative 1. To the right, we have a 2 and a 3. And so lay out our table here, x values, y values. I need 2 values to the left of the vertex. My vertex is 1, negative 2, I think. Yep. And I need 2 values to the right. So to the left, I could use 0 or negative 1. To the right, I could use 2 or 3. And now remember, everyone, these parabolas are symmetrical. I am going to go through the work of doing all of these points, but recognize that if you get the left side done or you get the right side done, you can just flip it over and it's going to be the same because parabolas are symmetric. And so to start with, I'm going to go ahead and put our x value in of negative 1. And so we will have y equals negative 2 times our x value is negative 1 squared plus 4x, and our x value is negative 1 minus 4. So y is equal to 2 times 1, because negative 1 times negative 1 is positive 1, plus a negative 4 minus 4. So we've got y equals 2 minus 4 minus 4. Y equals 2 minus 4 is negative 2, minus 4 is negative 6. And let me double check to make sure I did my math correctly there. I think I might have made a mistake. I did. I forgot to keep the negative on that 2 right there. And so that's going to make that a negative 2. And that's going to cause some other changes here. So forgetting my negative on that 2 messed me up. So negative 2 minus 4 is going to be negative 6 minus 4. Negative 6 minus 4 is negative 10. So similar to the last one, our x value is negative 1. Our y value is 10. So negative 1 and 10. Next, I'll do the 0. So y equals 2 times our x value, which is 0 squared, plus 4 times our x value, which is 0, minus 4. And 0 squared times 2 is going to be 0. 4 times 0 is going to be 0. And so we've got y equals negative 4. So when our x value is 0, our y value is negative 4. Now, as we talked about in the last problem, this parabola is going to be symmetrical, so I already know that's going to be a negative 4. Isn't that 10 negative? Man, I keep messing up with negative signs today. And I know that that's going to be negative 10 because they have to be mirrored across the vertex. And so I'm going to go ahead and do the work to show that when I put 2 in there, it's going to be negative 4. And when I put 3 in, it's going to be negative 10. But I already know what the result is going to be. So we got y equals negative 2 times our next value is 2 to the power of 2 plus 4 times 2 minus 4. Y equals negative 2 times 4 plus 8 minus 4. Y equals negative 8 plus 8 minus 4. Negative 8 plus 8 is 0. And y equals negative 4. So when our x value is 2, our y value is negative 4. We already knew that that was going to happen, though. And lastly, our x value of 3 we've got negative 2 times 9 plus 4 times 3 is going to be 12 minus 4, and that gives us negative 18 plus 12 minus 4. Negative 18 is negative, and positive 12 is negative 6 minus 4. Y equals negative 10. So when our x value is 3, our y value is negative 10. And again, we already knew that. So this parabola does open down because our leading term is negative. And so we will have 0, negative 4 right there. And negative 1, negative 10 right there. And then our other points mirrored on the other side. So again, not a point here at the bottom, but a kind of an upside down bowl. And that's what we end up with for a graph. Again, number 3 was a lot of work, just like number 2 was. Not super difficult, just time consuming. Hope this is helpful, and I hope you have an awesome day.